So let's resolve a rational fraction into a partial fraction using the second type of partial fraction resolution. Over here, things are a bit different than the last time we touched this topic. Over here, you actually have this part, this denominator, and that will actually be resolved by the second type of partial fraction resolution. But it also being multiplied with this linear expression. So how will you deal with this? Well, it's somewhat similar to what we did before. Well, you'll first have to resolve the x plus 2 whole square part of the denominator. And how will you do that? Well, as you remember, you'll have you'll have two partial fractions over here, obviously in increasing powers of x plus 2. So we'll have a over x plus 2 to the power 1 plus b over x plus 2 to the power 2. And obviously that is the limit. That is the highest, or that is the highest power of x plus 2. So that is where you'll stop with this part of the denominator. And then you'll have to also put in another partial fraction for this x minus 1. So you'll have this c over x minus 1 for this. And now you have to resolve it. So obviously, as with every other partial fraction resolution we've done before, you'll take the LCM of these three. So a will be multiplied with, basically you need this in the denominator, this x plus 2 whole square into x minus 1. So we already have this x plus 2 expression over here. It needs to be multiplied with another x plus 2 and obviously x minus 1. So a will be multiplied with x plus 2 and x minus 1. B has x plus 2 whole square, so it just needs to be multiplied with x minus 1. So b will be multiplied with x minus 1. And c is missing this, the denominator of c is missing this x plus 2 whole square. So c will be multiplied with x plus 2 whole square. And then obviously the denominator is also be multiplied with the same numbers, the same expressions. And so you'll have the denominators equal to each other. Now they can be cancelled. And basically you now have the numerators equal to each other. And so you'll get this expression. And obviously after multiplying x plus 2 and x minus 1, you get this expression, this quadratic expression. B will multiply with bx minus 1, so you'll get bx minus b. And c will be multiplied with x plus 2 whole square, and that is basically the expansion of x plus 2 whole square. And after multiplying everything, you get this big equation. Now, when you put x is equal to minus 2 in equation 2, what was equation 2? This was equation 2. So when you put x is equal to basically 1, sorry, x is equal to minus 2 in this equation, every variable of these three variables, a, b, and c, the ones that are being multiplied with x plus 2 will be eliminated, because when you plug in 2 into the expression, this plus 2 will be multiplied with minus 2, and that will give you 0. So this entire expression will be 0, and c will also become 0 because this part will become 0. So you'll just be left with b into minus 2 minus 1, so b into minus 3. Let's see what happens. See, a will be multiplied with 0 and c will be multiplied with 0. b will be multiplied with minus 3. So we'll have minus 3b is equal to 9, and so the value of b is equal to minus 3. Now, when you put x is equal to 1 in the same equation 2 we did before, basically the a variable will be eliminated and b will also be eliminated. And we'll just be left with c, and that is equal to x plus 2 whole square. And so, since the value of x is 1, 1 plus 2 whole square, so that becomes 3 square. And so 9c is equal to 9, and so c is equal to 1. We have found the values of b and c. Now let's just find the value of a. So we need equation 3. So what was equation 3? Well, this was equation 3. And basically we'll just have to see what happens. Well, look over here. As you know that the component of x square in equation 3 is a plus c. Let me show you again. Look over here. A and C, A plus C. These are the coefficients of x squared. But you notice that on the left hand side, you have no expression for x squared. You have no coefficient for x squared. So that is why the coefficient of x squared will be equal to 0. So a plus c is equal to 0. And so when you plug in the value of a, and what did you find the value of a? Oh, sorry. When you plug in the value of c, sorry, you found the value of c to be 1. So when you plug in the value of c, you find that a plus 1 is equal to 0. And so a is equal to minus 1. Now we found the values of a, b, and c, and when you plug in those values in the original partial fraction that we found, you get this. And so you have resolved the equation given in the question into its partial fractions.